Now, folks, we've been talking about visible light, and I want to spend just a few minutes talking about color. Color is very, very closely related to visible light, and I love color, and so I wanted to spend a little time talking about it. The color that an object appears is the color that it actually reflects. If I have a red apple and I am looking at it outside under sunlight, our solar spectrum is going to contain all the colors of the rainbow, Roy G. Biv. But of all the colors that hit the red apple, only the red color gets reflected to my eye, and that's why I see the apple as red. What happens to all of these other colors? They actually get absorbed and turned into heat. This is a cool collection of pictures, and it's showing grapes, a card, and a pepper under white light so that all the colors are visible, red light, and I love the fact that when you look at the playing card in red light, the red is reflected off of the white and the red, so you actually get no differentiation between the hearts and the rest of the card. Green light and then blue light. So the color that an object is the color that it reflects. And that color of light has to be present in the light or you can't see that color. One of my favorite examples is if you look at makeup counters or if you look at paint chips. Right above paint chips in most stores, they are going to have a collection of old-fashioned light bulbs that are going to give you full spectrum. These bulbs are going to be Roy G. Biv, all the colors of the rainbow are going to be in the light bulbs above the paint chips or above the makeup counter. The rest of the store usually is going to use cheap fluorescent light bulbs, and fluorescent bulbs do not contain all of the colors of the rainbow. And that's one of the reasons why color matching is so difficult under fluorescent lighting. You have to have full spectrum light in order to do a good job of color matching. If you buy light bulbs, one of the things I find fascinating and really confusing is light bulbs are sold in Kelvin temperature. Now, if you remember, Kelvin is the temperature scale and 0 Kelvin is absolute zero, where all motion stops. And it's very, very, very cold. So if you start talking about 2,700, 5,000, 6,000 degree Kelvin, you're talking about temperatures about as hot as the surface of the sun. Now, if my light bulbs in my house got as hot as the surface of the sun, oh boy howdy, my lamps would melt. My house would melt. It would be just nutty crazy. So how in the world can they sell light bulbs and have ratings on them that say numbers in Kelvin? How do they get away with that? Well, it relates to the fact that every object does not produce just light in the visible spectrum. It produces light all across the spectrum. It's going to produce some visible, it's going to produce some ultraviolet, some infrared, some radio waves. Every object that is warm or oscillates at all is going to produce a whole collection of different wavelengths. And the peak of this curve of the graph of all the different wavelengths it produces is the color that we're actually going to see. A graph like this is called a black body diagram. And if I see an object that has a peak right around the yellow-green, well, then we're looking at something that's going to appear yellow-green. Something that has a peak right around yellow or orangey-red, that's going to appear orangey-red. Something that has a peak into the infrared, it's actually going to appear a deep, deep red to my eyes, but that's not even the peak of the curve. Things that are very, very infrared, very, very, very further into the red and infrared part of the spectrum are going to be very, very dim and reddish. Now, why is this interesting? Well, we're still trying to explain those crazy light bulbs. If I see something that is like a piece of metal that's being heated, how about being heated? You may be aware of the fact that white hot is actually hotter than red hot. And again, we're referring to the peak of that black body curve. So something that is red hot, the whole black body curve is over to the right, and that means lower energy. Red basically means, when you're talking about visible light, lower energy. And the more blue, the more white, the more combination you get on the other direction, the higher energy. When we start looking at individual stars, because I also teach astronomy, red stars very often are going to be cooler on the outside temperature of the star. Yellow stars, like our sun, a little bit hotter. Blue stars, much, much, much hotter. And here's some lovely examples. Cool star, red end of the spectrum. Medium stars, white, yellowy white like our sun. And hot blue young stars like the stars in the Pleiades cluster, nice and bright and blue. All right. You can do this, and I think this is kind of fun. This is our old friend Orion. And can you pick out which stars are the hottest? Well, yeah, Rigel, Bellatrix, the 3 stars that make up Orion's belt, those are all really, really hot blue stars. Okay, who's nice and cold? Betelgeuse. Betelgeuse is a cold red star. This is the Orion Nebula. It's not really a star. It is a whole cluster of stars and gases. But it does look kind of pinky in there because that's a lot of hydrogen gas going on. So Betelgeuse is cold because it's red, and Bellatrix and Rigel are hot because they're blue. This gets very confusing because it's kind of opposite from water taps. Now I'm doing all this so you can understand your crazy light bulbs. When you look at the numbers that are given on light bulb packaging, that is related to the peak of that black body curve. So the spectrum that is emitted by this light bulb peaks at 2700 Kelvin. That is a lot cooler than the peak of this light bulb that's going to peak at 6000 Kelvin. And so this light, if you bought this, it is going to be light that is hotter and bluer, and this light is going to be cooler looking, and it is going to be redder. This is a nice little combination of pictures right here. Same scene, different light bulbs are used to illuminate it. You look at it with blue light, with more of a balanced middle of the road kind of a collection of light bulbs, and very warm light. All right, that will do for this part of visible light. We'll come back. We're going to start talking about ultraviolet.